Welcome to Mastering PyTorch Callbacks. Enhance your training workflow where you'll learn how to implement and utilize PyTorch callbacks to automate and enhance your model training process efficiently.
Welcome to our deep dive into PyTorch callbacks, a feature that might just revolutionize your training workflow. Did you know that callbacks can automate tedious training processes and enhance your model's performance? In this video, we'll explore how to implement and leverage callbacks to not only streamline your workflow but also boost the efficiency of your models. Get ready to transform the way you train models with PyTorch.
Let's start by understanding what PyTorch callbacks are and why they're beneficial. In essence, callbacks are functions or methods that are called at certain points during training. They enable automation of repetitive tasks, such as logging, saving models, and adjusting learning rates. By utilizing callbacks, you can significantly increase the efficiency of your training processes. Imagine not having to manually stop a training session because a certain accuracy is reached or adjusting learning rates on the fly. Callbacks manage that for you. They not only save time but also reduce the risk of human error, making them indispensable tools in your PyTorch toolkit.
Logging is a fundamental aspect of training models, and callbacks make it seamless. With logging callbacks, you can automatically track various metrics, such as loss and accuracy, throughout your training sessions. Implementing a basic logging callback involves defining a function that logs the desired metrics at each epoch or batch. This data can then be analyzed to optimize your models and understand their behavior over time. For instance, you might notice that after a certain number of epochs, the model's performance plateaus, indicating a need for different training strategies. By automating this process, you ensure consistent and reliable tracking of your model's performance.
Early stopping is a powerful technique to prevent overfitting and save computational resources. By using callbacks, you can automate the early stopping process, halting training once a specified metric stops improving. This ensures you achieve the best possible model without unnecessary training. Implementing an early stopping callback involves setting criteria, such as a minimum change in validation loss over a specific number of epochs. This callback will monitor the model's performance, and when it detects no further improvement, it will stop the training. This not only saves time but also ensures better generalization of your models. The learning rate is a crucial hyperparameter in training, but manually tuning it can be challenging. With callbacks, you can automate learning rate adjustments, ensuring that your model converges effectively. A learning rate scheduler callback monitors the training process and adjusts the rate based on predefined rules or the model's performance. For example, reducing the learning rate when the validation loss plateaus can prevent overshooting during optimization. Implementing this involves defining a callback that checks performance metrics and modifies the learning rate accordingly. This dynamic adjustment enhances the model's learning efficiency and can lead to better performance. PyTorch Lightning is an open-source library that simplifies the organization and scaling of PyTorch projects. It naturally supports callbacks, making it easier to integrate them into your workflows. By using Lightning, you can write cleaner, more organized code and easily implement and manage callbacks. The library offers built-in support for many common callbacks, such as early stopping and learning rate schedulers. Moreover, Lightning ensures that your model training is more reproducible and scalable, which is especially beneficial for large-scale projects. By leveraging both PyTorch Lightning and callbacks, you achieve a streamlined training process that's both efficient and effective. While there are numerous built-in callbacks available, you might encounter unique tasks that require custom solutions. Creating custom callbacks allows you to incorporate specific logic tailored to your project's requirements. Whether you need to implement a bespoke metric or manage complex logging, custom callbacks can handle it. The process involves defining a new class that extends the base callback class, implementing the desired functionality within its methods. Testing and refining these callbacks ensure they perform as expected. By crafting custom callbacks, you can address any unique challenges your project presents, ensuring flexibility and precision in your training workflows.
To truly appreciate the power of PyTorch callbacks, let's examine their application in real-world projects. In one case, a team faced challenges with model overfitting and inefficient training. By implementing early stopping and learning rate scheduler callbacks, they significantly improved their model's performance and reduced training time. These callbacks provided automated solutions to common issues, demonstrating their efficacy in practical scenarios. The project highlighted the importance of embracing automated solutions for complex training workflows. The lessons learned underscore the value of callbacks in enhancing efficiency and effectiveness, offering insights that can be applied to your own projects.
Implementing callbacks effectively requires adherence to certain best practices. Begin with a clear understanding of your training objectives and the specific tasks that callbacks can automate. Avoid common pitfalls, such as overcomplicating logic or neglecting thorough testing. Ensure your callbacks are efficient, minimizing computational overhead. Regularly test and validate their performance, adapting them as your project evolves. Continuous improvement and refinement are key, as models and training objectives change. By following these best practices, you'll maximize the benefits of callbacks, achieving streamlined workflows and superior model performance.
In conclusion, PyTorch callbacks offer a transformative approach to model training. By automating critical tasks, they enhance efficiency, performance, and workflow management. We've explored various types of callbacks, from logging to custom implementations, and seen their real-world applications. Now, it's your turn to implement callbacks in your projects and experience these benefits firsthand. I invite you to share your thoughts, experiences, and any questions in the comments. Don't forget to like, share, and subscribe for more insights into mastering PyTorch and other data science tools. Let's continue this learning journey together.